a speaker and participant here, and that is Arnie Gundersen, Chief Engineers at Fairwinds Associates. And let me just tell you that this man really knows what he's talking about. He has managed and coordinated over 70 nuclear power plants here in the United States. Yeah?
People working it.
All right, he's been at 70 and had people working. Look, he's been very, very active, and you know, he's worked in the industry. You know, he has a fellowship and a master's in nuclear engineering. He holds a nuclear safety patent, licensed reactor operator, a former nuclear industry senior vice president, and you know, now you know, he's obviously still very active in the industry, has a lot of thoughts, and so let me please invite you now to share our thoughts with us, please.
Yeah, thank you very much. I'm here with a couple of my heroes. You know that comment about speaking truth to power? Well, these three guys were in power, and they spoke truth to power, which is pretty impressive. I'd also like to thank Friends of the Earth for hiring me a year ago on the San Onofre issues and supporting that analysis. And finally, I have to thank the president of Fairwinds, my wife Maggie, who the strategic direction, you probably know us through our website, and the strategic direction on that site is hers. I hate to say it, but I did anticipate the accident. My wife Maggie and I were walking 3 weeks before the accident, and she said, if there's going to be an accident, where is it going to happen? And I said, I don't know where it's going to happen, but I do know it's going to be in a General Electric Mark I reactor, which is exactly what Fukushima Daiichi was. And I think within the NRC, that was a well-known weak spot as well. Next slide. What I'd like to talk today about is can Fukushima Daiichi happen here at San Onofre, and would our regulators behave any differently than the Japanese regulators did in giving information to Prime Minister Khan? Next slide. The first question is what is a nuclear meltdown, and what does it look like? This is a nuclear fuel rod, which was given to me when I was an executive in the nuclear industry. It doesn't have nuclear fuel in it, that it's made of zircaloy, and a nuclear reactor has no off switch. When you shut a nuclear reactor down, the chain reaction stops, but the radioactive rubble that's left behind from the splitting of the uranium atom remains physically hot for 5 years. So what happens is if it doesn't continue to get water, it turns that color and begins to burn in air. And it creates a fire that water doesn't put out, pyrophoric. Matter of fact, it sucks the oxygen out of water to burn and liberates hydrogen gas. Next slide. Well, this is what happens when hydrogen gas is released in a nuclear reactor. This is a slide of from the right to the left. The first box is Daiichi 4. The second box, the one in the middle, is Daiichi 3. Then Daiichi 2, and Daiichi 1 had already blown up at this point. And we'll shoot through real quick the next 18 slides. This is not supposed to happen. This is a detonation shock wave created by that hydrogen that destroyed the containment structure at Daiichi Unit 3. The probability of that, if you believe the Nuclear Regulatory Commission's risk analysis, is about once in 200 years, and it happened 3 times in 3 days at Daiichi. As a matter of fact, if you look at the history of nuclear meltdowns, we've had 5 meltdowns in 35 years. We had 3 Mile Island, partial meltdown, Chernobyl, and 3 meltdowns at Fukushima. So it's 5 meltdowns, 35 years, meaning the chance of a meltdown somewhere in the world is once every 7 years. Well, how can there be such a big difference? The numbers from the NRC say, once every 200, and we've had 1 every 7 years. This is my favorite comic strip in the world. It's a Dilbert. And the secret is in the assumptions. It's not in these gigantic supercomputers that the industry uses. The secret is in the assumptions. The NRC knew that that the Mark I design was a weak one 2 decades before the Daiichi accident. This is a quote from Chuck Casto, who's a very senior person at the NRC, 5 days into the accident. And he says, there's no doubt about it. When you have a station blackout, you're going to lose the containment. So what happened at Daiichi shouldn't have been a surprise, but yet it was. It's another famous quote from the public relations people at the NRC. This is a collapsed cooling tower at Vermont Yankee. And the public relations person, before this picture was released by a whistleblower, he told the press that it wasn't really a collapse, it was a, quote, sagging deformation of some of the wood. So operating a nuclear plant is harder than rocket science. Next slide. It boils down to 2 things: the integrity of the components and the integrity of the people. This first slide compares the San Onofre units, the tube integrity, to every other nuclear reactor in the country. The 2 red bars on the left are San Onofre Unit 3, it's the largest, and San Onofre Unit 2, which is the second largest, compared to every other nuclear reactor that has replaced their steam generators in the world. So that speaks to the integrity of the components. The next slide is a comparison of whistleblower complaints at San Onofre. And again, San Onofre leads the nation in whistleblower complaints. So we've got a system that has compromised integrity on both the people and the parts. And that's what makes San Onofre unique, is that the process there where people feel safe to talk about these issues is compromised. I work at plants all around the country, and and 1 or 2 whistleblowers will contact me if I'm working on a plant with a concern. At San Onofre, I've had 12 contact me. I've never seen that level of employee discontent. Then I think that speaks to the problems at San Onofre as much or not more so than the 500 tubes that were plugged. Next slide. On the integrity issue, this is a picture of the guts of a steam generator as it's being built. And that large cylinder in the middle is a stay cylinder. This is Palo Verde. That large cylinder was removed at San Onofre, and yet the Edison, the owner of San Onofre, didn't tell the NRC about it and claimed that the replacement generator was a like-for-like replacement for its original steam generators. That's what they told the NRC in 2006. But in 2004, Barbara Boxer has released a paper that says that that they knew in 2004 it was not a like-for-like replacement. But yet when they went to license it, they told the NRC in 2006 it was. And in 2012, they told the NRC that it was not just like-for-like, it was improved like-for-like. in a nationally publicized paper. And that gets to this integrity issue again. In 2006, that was the peak year for whistleblower complaints at San Onofre. So, and I believe there's a direct relationship there. The integrity of the people affected the integrity of the parts. Okay. Moving forward, Edison's own consultants can't agree on the cause of those tube failures. Arriva says they're one thing, and Westinghouse says they're the other. Edison's analysis has never been tried before in licensing of a nuclear plant. The Friends of the Earth, the pressure, the Nuclear Regulatory Commission and the Atomic Safety and Licensing Board agreed that moving forward with Edison on San Onofre without a public hearing would be an experiment. And with 8 million people within 50 miles, I don't think that's an experiment that I'm willing to take the risk on. So what would an accident look like at San Onofre if one were to occur? I was in Tokyo in February of last year on a book tour, and I was on the roof of my publisher's office building, Shueisha, and I took a dirt sample. This is me collecting dirt on the roof of the office building in Tokyo, and Tokyo is 140 miles, about 200 kilometers away from the Daiichi accident. I did that 5 times throughout Tokyo in 5 days, in front of their judicial center, on a public street, in front of a religious center, and I brought the samples back, next slide, and all of them tested as high enough to be treated as radioactive waste here in the United States. That dirt on the sides of the sidewalks would have to be shipped to Texas in drums and stored for 500 years. And yet, in Tokyo, we're letting people walk on sidewalks, essentially with radioactive waste on the sides of them. And San Diego is a lot closer than Tokyo was. I mean, San Diego is 30 miles roughly, and here's Tokyo at 140 miles, contaminated to that extent. Next slide. We put word out we asked for people to send us car air filters. And the car air filter, these are 3 car air filters. The one on the right is Fukushima City, which is approximately the same distance from the Daiichi units as San Diego is from San Onofre. Each one of those black spots on there is a piece of radiation that got trapped onto the air filter of the car. Turns out a car engine breathes about the same as a human lung, between 10 cubic meters and 20 cubic meters a day. So it's safe to assume that if that's in the car filter, it's also in the people's lungs in Fukushima City. Tokyo's in the middle, and not much better. And actually, the Seattle filter actually had 1 hot particle make it across the Pacific as well. Next slide. We also asked for kids' shoes. These are kids' shoes from Fukushima City. Again, the same distance from the accident as San Diego is from San Onofre. And the radioactive concentration on those shoes, particularly in the laces, was essentially off the charts. Unfortunately, it's not just the shoe. There was a kit attached to that shoe before they mailed it to the United States. Next slide. I'm sure you've heard that no one will die from Fukushima Daiichi, and no one has died from nuclear reactors here in the United States. The NRC's own website says that no one died after 3 Mile Island. This is a map of the within 10 miles of 3 Mile Island. 3 Mile Island is a little dot right in the middle of that. The white line that goes off on the diagonal is the Susquehanna River. On the day of the accident, there was very little wind, and the radioactive contamination got stuck in the river valley. The colors you see on that chart indicate the cancer concentrations of lung cancer alone that developed within 10 years of the accident. This is peer-reviewed. This is Dr. Steve Wing's analysis of the accident, and it shows that the cancer incidence from lung cancer alone is 150% higher than normal. And yet the NRC's website will say there's no one died from 3 Mile Island, and the IAEA, the international agency that supposedly is a watchdog and in fact is by charter a proponent of nuclear power, will say that less than 100 people will die from Fukushima Daiichi. In light of Dr. Wing's work, I can't believe that to be true. Next slide. Prime Minister Khan said that our existence as a sovereign nation was at stake. When you consider evacuating Tokyo with 35 million people, that goes beyond monumental decisions. Mikhail Gorbachev, in his memoir, said that the real cause of the collapse of the Soviet Union was not perestroika. It was Chernobyl. So we're dealing with a technology that can have 40 great years and one bad day. And the one bad day is bad enough to take out a country. So, as I said on the bottom there, at what point does the risk of a technology become untenable? My takeaway from the Daiichi accident and really the reason I continue to work on San Onofre is the last slide. This is my quote. Not quite as eloquent, but next slide. Sooner or later, in any foolproof system, the fools are going to exceed the proofs. And last slide was some credits. Thank you very much.
Thank you very much for your presentation, and what we're going to do now is go to a final presenter, and then we'll have our panel discussion, and then we'll have questions from the audience.